Hey everybody, I'm back. Problem number 8 here. I'm going to rewrite, I don't know how, but somehow this got split into 2 different pages. So I'm going to rewrite this quadratic here in the space provided. And we're yet again going to use our sum and difference, sum and product rules of quadratics of any polynomial for that matter. A squared plus alpha squared plus beta squared equals 4. This is really glitching on me. Try to move this up to the top. Find the possible values of k. All right, so sum, recall. So this will be alpha plus beta will be equal to the opposite of the term after the leading term if it's in standard descending form, right? So in this case, that'd be the opposite of negative 2k over the leading coefficient, which is 1. So alpha plus beta is going to equal 2k. Okay, the product will be equal to alpha times beta, which is negative 1 to the nth power. In this case, that'll be a 2. Times the constant, k minus 1, all over 1. So alpha times beta equals k minus 1. All right, so we've got this. And then they give us this clue. Alpha squared plus beta squared is 4. All right, and at this point, you need to be able to deduce. It says don't just solve the formula, but find an alternative way. Right? I find an alternative way to solve instead of the quadratic formula for said thing to find the value of k. So you need to be able to deduce that alpha plus beta quantity squared is going to be equal to something that relates to said things. All right, so you can see that alpha squared plus beta squared is going to be our hint here. And 2 alpha beta is 2 of those. And of course, alpha plus beta is 2k. So now we roll. This is 2k squared. I'm going to simplify this to be 4 plus 2 times k minus 1. And it looks like we're going to have a quadratic to solve. So this will be 4k squared equal 4 plus 2k minus 2. So 4k squared is equal to, it looks like 2k plus 2. And now we roll with it. Whoops, I didn't want equal. I want to subtract 2k minus 2. Set it equal to 0. Let's zoom in here. Factor. All right, so I'm under the gun, under the pressure. I haven't done this problem yet, so let's factor this thing. I'm going to go likely, let's go 2k and 2k, it's a guess. And let's go, I don't know, let's try minus 1 plus 1. Nah, that wouldn't work. You know what? I think we might need a 4k. No, you know what? You know what'll make this all easier? I don't know why I didn't do this at the beginning. Let's take out a 2. That'd be 2k squared minus k minus 1. Okay, and then let's factor this. This will make it a little bit easier, give us less options. Good strategies along the way. All right, let's go plus 1 minus 1. I think that's right. Let's see. That would be 2k squared. That would be plus 2k. That would be minus k. That would be minus 1. We're good. Good to go. Nope. Wrong. Mr. Ludd. Wow. Fail. I want this. I want this to be a minus and this to be a plus. You know, it's good making mistakes. Shows we're human, and I am very human. So let's figure out what values for k would make this true. Looks like -1/2, and that was supposed to be a negative, so a +1. Those values for k would make this true right here. Okay, found the possible real values of k such that the sum of the two roots is negative, or is positive 2k, and the product of the two roots is k minus 1. All right, folks, if you got questions, yet again, as always, let me know, and we'll get it figured out together.